Okay, let's get started, guys. So we're going to listen to a talk by Aleksandr Kuzmenko. The title of the talk is Haxe transpilation to PHP, static typing, arrow functions, metaprogramming, and more. Okay, let's get started. Thank you.
Okay. Hello. So I was a professional PHP developer for almost 10 years, and now I'm a developer of the Haxe compiler. So I kind of know what I'm going to talk about. A small introduction: what Haxe is. It identifies itself as the cross-platform toolkit, which consists of an open source cross-compiler, which compiles the Haxe programming language to the different target languages and virtual machines. Also, the toolkit contains the standard library, which is completely cross-platform. That means you can use that library targeting any available language. Also, the toolkit provides different ways to access native capabilities of the targets. So the targets are the target languages are some like JavaScript, Python, PHP, C#, Java. There was something else, I just don't remember. Also, Haxe can target some virtual machines directly. That means that it compiles Haxe to the bytecode, like for example, for Flash, for Java, JVM, since the Haxe 4. So Haxe and PHP are in long-term relationships since like 2008. The previous versions of Haxe was able to compile Haxe to PHP code, which was compatible with the PHP versions of 5.4 and higher. And the newest Haxe 4 is targeting PHP 7.0 or higher. So why do you want, as a PHP developer, why do you want to use Haxe? Mostly it's because you can share your code between your PHP server and any other technology client. For example, if you're developing a web service which consists of a server written in PHP using, for example, Laravel framework, and you need to provide some SDK for integration with the client-side applications, for example, written in JavaScript or Java or C# or something else. And usually you have to write some parts of your SDK and your server multiple times. Just like in that example, I extracted the networking layer to showcase the. So in this example, you have to develop networking 4 times, each time in a different language for different targets. But with Haxe, you can actually develop that networking layer one single time and then compile it, transpile it to different targets. You hit the button and get the server code, get the PHP code out of your Haxe library, get the JavaScript, Java, C#, Python, C++, and all of that just from the single code base, which greatly saves you time needed to develop your web service. Another example is a game application, and I was participating in a project like that. That was a game, something like Clash of Clans. It had a server written in PHP and mobile and browser clients. Mobile clients were written in, for example, C#, targeting Xamarin, and browser client may be written in JavaScript using Phaser framework. And the kind of a core gameplay feature of the game is the battle. It's when player releases his units on some hostile village, and units run around destroying the village, robbing warehouses, storages, and all stuff like that. And again, we had to implement it multiple times for the C# or JavaScript, and to validate that our players are not cheating, not faking the battle results, we had to implement the same battle logic on the PHP server. But through the lifetime of the project, it was like 5 or maybe more years, the implementation differences accumulated, and because all 3 targets were handled by different people, they implemented the battle logic in their own way, and there always have been some differences in implementation. And so the differences accumulated through the years, and in the end we had almost no reliable way to detect cheaters without punishing the honest players. Because one time we did more strict checking, and then we got a lot of false positives for normal players, which were not cheating, but got their battle results discarded, because server was not able to reliably reproduce the client logic of the battle system. And then we decided to move the battle logic to Haxe, and got something like this. And that made us possible to detect cheaters 100% precisely, because the same code, the same logic was compiled to server and to clients. We had no differences in battle simulation on client and server, so we always was able to detect cheaters precisely. And that not only eliminated the cheating problem in our project, that also allowed us to reduce the cost of development of new features in battles, because you don't need 3 or 4 people to develop the battle system for each target. Now you need only the single programmer who can write in Haxe and target all these applications. So how Haxe is different from the PHP? It's actually pretty familiar. It has pretty familiar syntax. For example, in this PHP class, I'm dumping the string to console, and this is how it looks in Haxe. It's almost the same code, except that you have to import PHP functions into your current module. But the syntax looks exactly the same. The Haxe syntax not always exactly the same, but most of the time it looks very, very similar to PHP. Here's how that Haxe code is compiled to PHP. Here's what you get after the compilation. Since Haxe is a strictly typed language, the compiler adds doc block comments where he hints the argument types and return types, so you can attach the generated code to your existing PHP project and get nice auto-completion for arguments and function types in your favorite IDE, which probably is PHP Storm. So another syntax. Now I'd like to mention some syntax differences, which maybe not, which are not so familiar maybe for PHP developers. For example, here is how you write an anonymous function to manually sort the array. This is somewhat nonsensical example, but it makes no sense in real world, but it allows to demonstrate the possibilities of Haxe syntax. So here's the anonymous function, which captures the outer local variable desc and modifies that variable inside of an anonymous function. So in PHP, you need to manually specify which variables should be available in an anonymous function. Also, if you want to modify those variables inside of a function, you have to add an ampersand. Here's how the same code looks in Haxe. Haxe can automatically find which variables you want to use or modify in your function, and you don't need to manually specify those variables, so there's no keywords like use or something like that. Also, you may notice the differences in variable declaration. It's no ampersands. Haxe can find out that the identifier is if identifier is a variable or some sort of constant, but instead you, at the declaration side, you have to use the keyword var to hint the compiler that this is actually a variable. And also Haxe 4 has an arrow function syntax, which PHP lacks for at this moment. I know that in PHP 7.4 there will be something similar, but still you have to use a keyword before the arrow function. In Haxe, arrow function is, I think, looks better than the proposed syntax for PHP. So another difference is, I'd say it's a major difference in syntax, because in PHP you have a traditional C-style switch, but in Haxe, switch is actually something more. First of all, you don't need to use break in the end of each case. There is no fall through, and also you can combine different cases with the vertical line instead of duplicating the case keyword. But what's more in Haxe switch is that actually Haxe switch uses the pattern matching. If you're not familiar with the feature, it may look something like this. You can switch, for example, on an array, and in cases you specify how that array should, what content of that array should be to fall to each specific case. The underscore symbol here indicates that you don't care which value is the specific index in array. For example, the first case will be executed only if array consists of 3 elements, and the element on the 0 index is 1, and on the second, the index 2 is 3. Also in Haxe, everything is an expression. That means that, unlike in PHP, where you force it to use curly braces, you can actually write much shorter version of this example in Haxe, which will look like this. That means you can return a value from try-catch or from an if or switch statement without writing return inside of that try or switch, because try or catch in this example, compiler knows that you want to return something, and the compiler propagates it to the parent expressions. So also Haxe has static typing. Now PHP is slowly moving towards stricter typing since like PHP 5.3 maybe. Now in PHP we have type hints. You can type hint function arguments, return types, and even in the latest versions you can type hint even class fields. But what's great about Haxe in this terms is that Haxe is already strictly statically typed. So you always have a specific type for some symbol. For example, in this sample, function return string is typed as function which returns string, and then compiler knows that s variable is of type string, and it prevents you to pass that variable to any place which expects, for example, integer instead of string. You will get a compilation error before running. You don't need to manually specify types for symbols. Just in PHP, if you want types, you have to type hint the variable or argument or return type. But in Haxe, like in this example, compiler can infer the type of the variable based on the usage of that variable. For example, from the first line, compilers see that the programmer compares a to integer, and then the inferred type of a is integer. Then from the second line, compiler infers the return type of the function as a boolean. That means that on the second return, compiler will not allow you to return string because the function is already typed as the function returning boolean value. Also, there's no auto-conversion between types in Haxe. You always have to manually specify if you want something to be converted to another type. What does it mean is that, unlike in this example of PHP code, which despite being type hinted as returning an integer value, the PHP interpreter allows you to actually make a statement of return string. But since that string contains an integer on the first character, PHP tries his best to convert the string to integer for you, and it just returns 1. And that's I think is a bad thing, because usually you're not aware that you are trying to return string in your real code if this situation happens. And in Haxe, compiler will throw an error at you at compilation time before running your script, so you are aware that you made a mistake somewhere in your code. Also, Haxe has not only a statically typed system, but it has a really rich type system. I don't think I have time to go into details about the type system, that's a separate topic, but I'll like to just mention some features. For example, function types. That means you can type hint functions with and inside of that type hint you can specify the types of each argument or return value, and you can specify that a variable holds a function, and that function accepts integers and returns strings, for example. Also, Haxe type system implements generic or parameterized types. That means that all your arrays are always known, all your array items are always known which type they hold. So if you spot an array in a code, you always know it's an array of integers or array of booleans or something like that. Also, Haxe supports enumerations. That enumerations is the complete set of some values, like for example an enumeration of colors, when you have red, green, blue color, and when you switch on a variable of such an enumeration, the compiler will let you know if you switched on all of the values of that enumeration or you missed some values. Also, generalized algebraic data types. If you know what it is, good for you. If not, I'm not going to talk about it right now. Anonymous structure types allows you to declare objects without declaring the classes for them. Also, Haxe implements cost-free abstraction types. I also will not talk about this, but if you're curious, you should really read about it. It's a very powerful concept. And all of the type system is compiled to ordinary PHP classes, which perfectly runs in any PHP runtime from 7.0 and higher. Now I'd like to mention some metaprogramming power of the Haxe. It's called macros. Macros are executed at compile time before running your script. So when your program is compiled, it runs a sub-program of your code, and that sub-program produces another code. So it's like a program which creates another program at compile time. Macros are written in plain Haxe code and are part of your Haxe project. They have full access to abstract syntax tree, so you can modify or inspect syntax tree at compile time using macros. Macros can generate new expressions or modify existing types or build new types. Now I'd like to give a few examples how macros can be useful for PHP programmers. For example, a common task in PHP is routing of web requests. Let's say you have this simple router which implements display routing a page and the logout features of your application, adding a macro which will inspect the syntax tree of that router. You can generate a code which will then be compiled to this PHP code. So you don't have, if you have in your Haxe code functions called page and logout, then macros will build for you a router function which will redirect the HTTP queries to the required function. So you don't need to write these if statements for each route in your application. And you don't need to parse JSON config files or something else. This is just generated at compile time and works super fast. No reflection, no something like that. Another case is auto-validating JSON at parsing. For example, you have a data class which you want to calculate from the JSON data. You can write a macro which will do that for you, but also that macro will, since macro has access to the structure of data class, you can automatically generate a code which will validate the JSON data for you and will throw an exception. So you won't miss any corrupted data received from user or from other sources, from third-party servers. That data will be validated automatically. That means that you have single macro and you can parse a syntax tree of the supplied class and generate required checks for the parsed JSON. So now I'd like to mention some implementation details. I have a few minutes left. The differences may hit you quite hard if you're not aware of it. For example, the string in Haxe is Unicode aware, but in PHP the string is binary safe. And it also super fast if you not care about multi-byte characters. Unlike in Haxe, string is automatically Unicode aware and it handles multi-byte characters. String is also a class at compile time. So in the Haxe code, string is represented like an instance of a string class, but it is compiled to ordinary PHP string literals. So because of its Unicode aware, then that means that methods of string class may be much slower for random character access. but you can always use native PHP functions to operate on a string, ignoring the Unicode. For example, to demonstrate the differences, here is the PHP code which handles or not handles the Unicode in a string. And here's how the equivalent hex code looks like. So, as you can see, you can use ordinary PHP functions to ignore Unicode, or use the hex string API and get the proper Unicode support. Another difference is arrays. In hex or in PHP, arrays are passed by value and can have numeric or string keys, and it's also okay to have holes in indexes of arrays. Unlike in hex, array is passed by reference and its class, and it can hold only numeric continuous case, so no holes in indexes are allowed. You cannot have an array of indexes 0, 1, 5. For that purpose, in hex we have another data structure. I will not talk about it right now, out of time almost. So here's an example of array mapping in hex. For example, you have this array. You can map using array API in hex and arrow function. Here's how it looks, and here is how it is compiled to PHP. So as you can see, the anonymous function is completely eliminated, and Haxe inlined all the code for you. So this short hex code is compiled to just a loop traversing the array. And since array has different semantic in hex, we have to wrap it in an array, in a class, implementing hex array semantics. You can of course use native PHP arrays in hex. You just have to use PHP functions for that. Also, another detail is anonymous objects. I don't think I have time, so I just skip it. Here's how it looks. So I just skip it. My slides will be available later, so if you want, you can check it. Interoperation. Yeah, Hex can easily interoperate with the PHP code. I think I have to skip it now too. You can inline hex code, PHP code directly into your hex code, or you can use PHP classes in your hex classes. Now I just want to mention some other features Hex has, but which are not exist in PHP. These are real properties with getters and setters. So when you start to creating your class, you declare fields, and then if you want to change a field to some getter or setter, you can do it. And from other side, your code you don't need to change the code using that class. Hex has immutable fields and variables, static extensions, metadata. You can annotate your symbols of your code with some data, which will be available for macros, and you can use it in metaprogramming. Also, Hex has experimental and optional feature null safety. You can enable null safety for the parts of your code. Hex has conditional compilation, so you can include or exclude parts of your code for debug version of your application or for release version of your application. Also, Hex compiler is an advanced optimizing compiler, so the same code written in Hex and in PHP may be executed in times faster. For example, I've implemented a star algorithm. It's not a common task in PHP, just for test I did. And because of Hex performance optimization to the generated code, the Hex compiled PHP code executed like 3 times faster than manually written PHP code. You can discover more features on the official Hex manual, and that's all. Thank you.
Anybody have any questions?
No? Okay.
All right, thanks a lot, Alex.